All right. Thank you very much for coming. I've yet to have a talk where there was a lineup outside. I'm hoping, and I'm just going to selfishly assume that that was for me and not for the fact that the room was already full when everyone showed up. So my name is Mark Nunnikoven. I'm the Vice President for Cloud and Emerging Technologies at Trend Micro. As you probably noticed in the app, in the guidebook, this is a sponsored session. However, if you came expecting a sales pitch, you will be sorely disappointed. We have a great booth on the floor if you want to talk about Trend Micro products and solutions. We have a great team here who would love to talk about your solutions and how they can help you out. This talk, however, is all about security, operations, and how they can change when you move to AWS. So, as I said, my name is Mark Nunnikoven. You can catch me on Twitter, MarkNCA. They insisted I put some sort of sports jersey. They actually requested a hockey jersey since I'm Canadian, but I couldn't find a little peep with a hockey jersey on it. Though, ironically, I don't play hockey. So, as I said, this talk is about security. But most talks you go to for security are about strategy or about architecture or frameworks. And all that's very, very important. However, we tend to neglect talking about tactics. So the day-to-day of running security, right? It's all good to draw it out and to design a nice framework and say this is how we're going to do security. But what does that look like when you sit down to manage your deployment in AWS? So that's what we're going to talk about today. We're going to talk about tactics. And to understand tactics, what we need to understand is how security works in the AWS cloud. So all of you, this is an advanced session, all of you should be using AWS already in your organizations. A lot of learning at reInvent, a lot of great stuff to learn here. But you might not know how security is modeled for the AWS cloud. And to understand how that model works, first you need to step back and look at the traditional responsibility model. So if you still run a data center, this is how your responsibility matrix looks for security. Everything you see on this slide, so from facilities, physical, networking, the virtualization layer, into the OS, the apps, the data, it's a very simple model. In the traditional model, you are on the hook and responsible for absolutely everything you see here. So sometimes you'll delegate that out into a co-location scenario or to a service provider, but at the end of the day, you're responsible for everything. Pretty straightforward, right? Everyone's got that one? Yeah? I'm gonna get you guys interacting here. So everyone's got that one? Yeah. Right on, thank you. Okay, so that's the traditional model. How does that change when we go into the AWS cloud? Well, the good news, it's also a very simple model. It's called the shared responsibility model. It also has a very simple name because it's very, very easy to understand. We have the same basic attributes and areas we need to look at, but now we are sharing the responsibility for the security of these aspects with AWS. And in fact, it's a very handy split. Everything you see on the left-hand side is AWS's responsibility. Everything you see on the right-hand side is your responsibility as a user or a consumer of AWS's services. So AWS is now going to take care of all the facilities, all the physical aspects, all the networking infrastructure, and the virtualization layer, right? And then it's up to us as consumers to take care of everything else from there. So how many of you are full-time frontline security folks? All right, so pretty good showing. How many of you blindly trust the fact that you're offloading half your security load to a provider? You can tell the real security guys when they laugh when you say something like that, right? So yeah, we don't assume. We're very paranoid in security in general, so we take the good old Reaganism of trust but verify. And that's what you have to do when it comes to AWS. You have to verify what they're doing to hold up their end of the shared responsibility model. Now the good news here is that AWS has made this very, very simple for us to do that. So there's two URLs that you want to remember. They're very easy to remember. aws.amazon.com/security and /compliance. These are the two centers where they've pooled all the information to do with, oddly enough, security and compliance. So all of the great logos that Andy had in the keynote this morning about all the certifications that they've got, all the information around that is at the compliance site. All the information around shared responsibility and how to configure services in AWS is at the security aspect. So there you'll also find security best practice white papers from AWS, as well as a detailed breakdown of how in each service they tackle the shared responsibility model. So that's step one for verifying what they do. The second step is if you're undergoing an audit, and we're going to talk about auditing a little later on, you can open up a support ticket and ask for validation from from AWS's third-party audits. So on a regular basis, they have one of the big auditing firms come in and audit their activities. So their physical aspects, the process, all the controls they've got in place. And as customers of AWS, they'll provide that to us. You simply just have to ask for the support. So that's a great setup of how you can verify what AWS is doing. So that still leaves us on the hook for securing the other aspects of this model. So we have to apply, specifically for EC2, we have to worry about the operating system, we have to worry about securing the applications, and we have to worry about securing the data. Now, there's two outliers on this slide that you guys probably already going, why aren't you talking about those? So identity and access and security groups. And the reason why those are odd outliers is because these are services or functionality that AWS provides. But they still end up on our area of the shared responsibility model because we need to understand how those services and how those options work. So identity and access falls under the IAM service, and security groups are in VPC and EC2. So the example of why you and how you need to understand that would be for IAM. The root account. When you create a new AWS account, you get a root account. There's only 2 things or 3 things you should ever do with that root account. Enable the services you want on your AWS account, enable multi-factor authentication, and create a new admin user in IAM. That's it. Then that root account should go away, and you should never access it again, because that is the keys to the castle, right? Once you have IAM set up, now you have to understand how this works. It's a great and really rich policy framework to apply privileges. So you have users, you have roles that you can apply to objects, and you have policies that define what they can do. So this is really, for us as security folks, the first time where we can actually implement the principle of least privilege, which is a fundamental privilege in security, or a principle in security, where we apply just enough rules for something to get the job done. So a good example is CloudWatch logs. For CloudWatch logs, an EC2 instance should only ever need the rights to write a log. That instance doesn't need the rights to read the logs or to make any edits to those logs. It only needs to write new log information. So you can give it that privilege within IAM. So a bad example of IAM usage, you can create every user in your organization with ultimate privilege to everything. Here's my first security tip for you. Don't do that. That's dumb. Okay? That's going to bite you in the rump. So you need to understand how IAM works. The second major thing you need to understand is how security groups work. So these are the firewalls wrapped around your EC2 instance. That's the easy way to think about it. And you have to configure how these work, how they function. So another example of what you can do if you really wanted to. You can create a security group that allows all TCP, all UDP, and all ICMP traffic on every port from anywhere on the internet. Here's your second free tip. Don't do it, it's dumb. Okay? In fact, it's so bad that if you try to do it in the EC2 management console, it will pop up with no less than 3 warnings trying to stop you from actually completing that action. You can force it and keep going, yeah, I know, yeah, I know, yeah, I know, yeah, I know. But then they come back again with Trusted Advisor and pop up warnings in Trusted Advisor saying, hey, did you know that was a bad idea and you did it anyway? If you do it a lot, if you have all of your instances running with horrible security groups that are wide open to everything, you'll actually get a call or an email from AWS, their normal incident response team, saying, like, you're generating too much traffic. So there is a lot of activity and a lot of safeguards in place, but at the end of the day, it's up to us as users to understand how that works. So that's pretty clear. Everyone's got that? Understand that's the framework we're working with here? Yeah? Good. Okay, so what we're going to tackle today. We're going to look at 2 of the 4 pillars of any security practice. We're going to look at incident response and everybody's favorite, auditing. Yeah, it was sarcastic cheers, but no real cheers, right? Except, and I didn't ask this one time and I got in trouble. I will take a quick break and ask, are there any auditors in the room? You are a brave, brave man. Thank you for answering honestly. So that changes some of how I will phrase things later on in the talk when we talk about audit. But thank you for being honest. Normally you kind of see a couple people at the back of them going, okay, for it. Because we tend to think of auditors like the lawyers of the security world, right? You know, everyone's got a good auditor joke. But they serve a valuable purpose, and we're going to tackle that in a little bit. But let's dive into incident response first. So for those of you on the front line, or those of you that have ever had to deal with an incident response within your security framework, this is probably a familiar feeling, right? Something hits the fan, and you don't feel good, because you know the pressure's on. In fact, you start to feel pretty quickly like this. Because the longer an incident is out, the more pressure you're under to restore production back, right? Because your business is there to conduct business. So a great example this time of year, Black Friday's coming up, right? If you take a server offline, you take your e-commerce site offline because of a security incident, how long do you think it's going to be on Black Friday before your boss comes down and yells at you? Yeah, mere moments. And if it continues and gets to 10 minutes or so, his boss is going to come, right? And then if it keeps going, you're going to get the director or the VP or the CEO. And the unfortunate reality is when they come to yell at you, they keep snowballing. They all come back. It's not like they take turns and come and yell at you to get things back into production. They come back as a team and then just keep piling on because it's easy to scapegoat the security guys because we took something out of production. So we want to fix that. So I'm going to show you what the process is for incident response and how we can improve it using a functionality in AWS Cloud. In fact, how we can get it so that we don't feel like we're running on the hamster wheel. So SANS, everyone familiar with the SANS Institute? Yeah, security folks are. For those of you that aren't, the SANS Institute is an independent organization. They take input from private sector, from public sector. They do a huge amount of really high quality security training, and it's almost always technology or vendor agnostic. Right? So they'll teach you about incident response in general or forensics in general, but they won't focus on a particular vendor's technology. They just try to educate and elevate. So this is their incident response process, and they wanted to pick multisyllabic words so it sounds really, really fancy, but it ends up being very basic. But it's prepare, identify, contain, eradicate, recover, and then the step that everyone forgets because no one ever has time is lessons learned. So you're supposed to actually go back after you've done an incident and then figure out what you could do better next time. But of course, there's normally another incident, so you don't have time to go back and everything just kind of queues up. So if you want to look at it another way, as far as weighted, if you look, these are the same steps again, represented visually instead. Most of your time is going to be spent in the middle section. You're going to be looking at identifying, at containing, and eradicating. And it tends to go in a bit of a circle as you play whack-a-mole with the attacker on your network. Okay? It's just how it ends up playing out. Nothing wrong with it. Now, there are a few goals for this. What we want to do as incident responders, for the business point of view, we want to ensure that we're quickly identifying what's affected. We want to try to minimize that impact, and we want to get production back as fast as we possibly can. We don't want to be hamster wheel guy, right? We're all getting enough walking as it is this week in Vegas. We don't need more running, trying to keep production back in running, up and running. So our traditional incident response process kind of plays out like this. We have a server. Something bad happens. We get some sort of notification from one of our security tools. The first thing we do in a traditional response is we isolate it. That's when the clock starts, because we've now taken something offline or out of production service. Now we go through and we do some analysis. We try to figure out what's going on. How bad is this? Is it going to spread? What steps do I need to take? So we do this analysis. Then we hopefully have some sort of strategy to try to repair. After that, we try to improve our defenses to stop this from happening again. Then we bring a replacement online, right? For those of you in response, that's pretty straightforward. That's kind of the general gist of it. Yeah. So when we move to the AWS Cloud, let's see how this changes. What happens now, we've got our instance. We find something bad on it, so malware, intrusion, something along those lines. We isolate it. But now we can bring up a replacement almost instantly. Then we can go through and do our analysis, do our repair, and then do our improvement. And the trick here is that we're going to actually automate that top piece, or we're going to turn off the presentation. There we go. So as a magic thing, when you turn off your presentation, that's when you just kind of cover your eyes and don't deal with the incident. Instead, you just crawl into the hope someone else is on the shift for the next hour that they can take it over. So we sit there, and what we do is we automate that top line. So we're going to automate the recovery process so that we don't have to worry about trying to get production back online. We're going to let AWS take care of that for us, while we then spend proper time doing the analysis and the repair and the improvement. So this gives us faster return to production. We're getting actual time. So I generously said more time. Realistically, it ends up being actual time to do some analysis because production is taking care of itself. Okay? So let's see that in action. And this is going to be a bit of a different demo. And it's a bit of a different demo because I switched it up and I went kind of cloud native for this. So what we're going to see is a security chat room, and hopefully that's going to be a better resolution. Otherwise, we're going to have some challenges here. Okay, well, we're going to work through this. So essentially what this is a chat room. And in this chat room is streaming real-time events. So you can somewhat make out that there is everything on the red icon is our security system. And what it's telling us is as it finds events, so the big red is really bad. It's found two events. It's found a malware event and it's found a content filtering event. So something is on this box and trying to go out. So what then kicks in is everything with the black box, which is actually a little tuxedo when it's displayed at the right resolution, is our automated script. And then the green blob, very technical term for the green icon, the green blob is CloudTrail. And what we've done here is we have a script that is reading the events, and it said there's a security event. I'm kicking in a new action here. And what I'm doing is I'm changing the AWS security group for our instance. And by doing that, we're making it fail its health check because it's attached to an elastic load balancer. Even if you're not routing traffic through that load balancer, you can still use it to hang a health check off of. It's a nice little trick. Okay? And then what we've done is the auto-scaling group uses the health check for the load balancer. And as soon as the load balancer can no longer talk to that instance, it takes it out of production and auto-scaling kicks back in. Now I know some of you are thinking, okay, well wait a minute, I only have one instance, I don't scale. Well, auto-scaling, as well named as it is for scaling, doesn't actually have to do any scaling. You can have a minimum and a maximum in auto-scaling groups of 1. So you can use this trick to simply bring your instance back online or bring a replacement instance back online. And you can see here from the blobby scrolling that what's actually happening is this attack is continuing. So we replaced an instance, and then that new instance got attacked again. So then our script kicked in again, and it brought back up. And because we're inputting the CloudTrail information into our chat room, we're seeing the activity in the background. So we know that auto-scaling's kicked in and it's been authorized and it comes back online for us. So what we've been able to do here is restore our production and buy time for our security team to actually look at the incident and try to improve it. And at this point, we've had 3 cycles through. The attackers popped 3 of our instances and auto-scaling has fixed each and every one of them. And it is actually written in English. So I do, at the end of this talk, I will send out a tweet with the links. I have posted these in HD like they were recorded, so that you can actually watch this and then go back and go, hey, that's what he was talking about. So what happens here is that we've got the 3rd and final time where our instance is getting popped. And at this point, there is a little security guy in here every once in a while saying something because he's trying to figure out what's going on. But in the meantime, he can spend the time looking at those instances because when we take them out of service from the load balancer, what we can also do is actually just detach them from the load balancer so that autoscale leaves them so that you can actually log in and see what's going on with them. And meanwhile, there's still a new instance brought back up into production so that you're all set. So here we've gotten to the point where we figured out that something is, we know what that attack is. We know what we have to do, and we have to change our security policy. So we're going to go in, you're going to see the little guy pop in a second here, and he's going to make a change to the security policy, and it's going to resolve this issue, because essentially what it was we didn't have enough control on our system, and that was allowing our attacker in. So what you've got here is very hard to determine when you're seeing it like this, okay? But what it is an illustration, especially through the chat interface. There's a reason why I really like this kind of a chat interface, is we've created in the background using AWS services a continuous event stream through SNS topics. So we have CloudTrail pushing out everything that's happening from the AWS APIs on a consistent basis into our SNS topic. And then what we've done in the background is configured our security controls to do the exact same thing. Then we've piped it all into a chat room. In this case, I just wrote a chat room in Node, but you could just as easily use Slack or HipChat or Campfire. Any of these services all allow either webhook or a direct API call. So you can integrate into more of a DevOps environment because you've created this continuous stream. So this will be clearer because it's actually, you can see it. I'm going to walk through it and show you the overview. And everything you're going to see on the left-hand side is completely automated and takes no action required from any of your operational team. Everything on the right-hand side is what the people have to do. Okay, so left-hand side, AWS Cloud and our script takes care of it. Right-hand side, we have to take care of it. So we have our instance. It is spitting out a constant level of logs. So you can use Cloud Watch logging. You could use your own logging. Whatever you want to do, you just have some sort of eventing system coming out of your instance. We find out something bad. Right? Our controls note there's malware or there's an attempt to connect to a CNC. There's some sort of bad thing that we've identified. At this point, our script will then identify said bad thing. It calls the AWS API, which then isolates the instance. And as soon as that instance is isolated, it fails its health check and a new one comes back up. Right? It's a nice little loop. Okay? And the beauty of it is if you're piping everything through SNS, SNS can respond to, it can push out to a JSON endpoint or to an HTTP endpoint. There's a whole bunch of options there that make it really easy to automate this. And in the tweet that goes out with the link, I actually have sample code that shows you how to do that. So if you want to do this at home, give it a shot, you can. So that's everything that's automated. What happens on our side? What do the security people have to do? Well, it comes down to 2 steps. We just have to do the analysis. So while this is happening any number of times that we dictate, we can do the analysis, and then we can improve our defenses and push that out into our security controls, into the automation, so that the next one that comes up, it's got the hole patched. Okay? It's got the fix in place. So a couple questions come up when I explain this kind of a workflow. They say, well, isn't that just always going to, what happens? Doesn't the replacement still have the same problems that the original instance does? And the answer is yes. It does have the same problems until you make this fix. Until you complete the loop of doing the analysis and improving it, it does have the same problems. However, if the attacker is just coming by and attempting once, you've removed the affected instance and replaced it with a good one, and you're good to go. Realistically, that's pretty unlikely. Attackers tend to be a little more persistent than give it a one shot and go. So what happens in the scenario where an attacker continues to try to exploit this instance, what you get is essentially the equivalent of that little kid's hand game. Is that the automation is taking the attacker's foothold in your deployment away, and yes, there will be production impact, but they're making no further gains into your deployment. So a very common scenario with any attack that we track is an attacker gains a foothold into your deployment, and then they use that as a hop-off point to continue to get deeper and deeper and deeper into your infrastructure. This will help keep them at bay. It destroys their beachhead in an automated manner until you can repair whatever vulnerability they were exploiting to go in. So it's a pretty cool technique, leveraging a lot of the power that's native into the AWS cloud. So now as I replay in my head how to make this super polite because we have an auditor, same guy. This is the same reaction if an auditor shows up. It's quite useful as a visual. If you're getting attacked, that's how you feel. If an auditor shows up, that's pretty much how you feel. So for those of you in the front line, how many have been through an audit? Yeah. How many were excited about getting audited? Yeah, nobody, right? No, one guy, okay, good. I'm hoping that's sarcastic, because, yeah, excited. Well, you didn't rip your hair out, so that's kind of excitement on the audit level. So what an audit ends up being is a huge amount of paperwork, right? And don't get me wrong, I have good relationships with a lot of auditors. They are great people. An audit gets a really bum rap when it comes to security, because at the end of the day, despite all the paperwork and the headache you have to go through, an audit plays a crucial role in our security practice. What an audit does is verify that everything we've designed and implemented is doing what we think it is, right? And that's a big hole in most security practices, is that we deploy all these controls and we do very little to test the validity of them. This is where audits come into play. Right? Auditors come in and they just not only look at your technology, is it effective, but they look at the processes you've put around it. So is your incident response, is your forensics response, are all these processes working the way you expect they are? So as much as we can make fun of auditors, they play a key, crucial role within our organizations, within our security practice. So let's take an example of PCI. PCI is the payment card industry. They have a pretty good framework around security. A lot of it should be your baseline security. It's a good reference point even if you don't need to adhere to PCI compliance. These are all controls. There's nothing in PCI that you should look at and go, hey, yeah, no, I don't need that. There's pretty much everything there should be considered security 101. So these are a few of the requirements pulled out of PCI. So encrypting data at rest, sure, great. This is my absolute favorite regulatory or compliance line. Is 6.6 here. Address new threats and vulnerabilities. Really? I have to do that? Like, of course I have to do that. Why is that even in the spec? But it's in the spec. So also logging and then protecting systems against malware. I'm surprised they didn't have like lock your door. Okay, so what that comes out to is when we look at in a traditional environment. So if we're looking at a data center, what we end up doing is having to pull information from all of these systems. Now on the bright side, most of them log, and in a traditional scenario, you'll have a SIM or centralized logging where you pull all this information to. But the weak spot of all of this is the change record. For those of you in operational roles, how often are your change records up to date? Yeah. So change records are well-intentioned. They're a good part of the ITIL process. But what ends up happening is they don't reflect reality, especially if you've got a short maintenance window and you have a lot of changes to do, is they may have been entered into the system, but the details don't get in there. So it's a bit of a black hole. But they're crucial for auditing because they not only say what happened, but when it happened and what the changes were and if there were additional challenges. So it's absolutely critical to have strong change records, but none of us do. And that's just the reality, so we all strive to be better. So when we move into the AWS cloud, there's another trick, there's some tricks we can use. So we look at the options of what we're logging. So now we're logging instances, and there's a change here where the perimeter controls that we had in our network deployment, in our traditional deployment in a data center, a lot of those network level controls are now moving directly onto our instances. So it's critical that we have really strong central management for our instances so that we can know at any given point in time what our instances are up to, what security controls are applied to them, whether they're active or not, and what policies are applied on top of those. Then we have all the AWS services. So AWS is starting to get more consistent, but there are still a few outliers. Most of AWS services log to an S3 bucket. And the consistency is great because it makes it a lot easier to automate what's going on. So the couple outliers are still RDS, simply because they're leveraging the actual logging out of the database. So SQL still logs like SQL, and same with Oracle. And there's a couple others there. But in general, you're going to get most of your logs into an AWS bucket. And then the unsung hero of last year's reInvent, CloudTrail. Right? And we saw some extra announcements and some more stuff beefing up around it from this morning's keynote. But CloudTrail logs almost every call that goes to the AWS API. And the beauty of it is everything in AWS goes through the API. Regardless of whether you're using a third-party tool, you're using the web console, or you're using the CLI, all of this is being processed in the back end through the APIs, which means it spits out in CloudTrail. So something like auto-scaling, you get an entry in CloudTrail that says auto-scaling requested a change, and then the authorization, the identity that was associated with that change. So you get this very strong audit log with much richer information. You just have to adjust how you consume it. And the bright side here, and the bonus you get with CloudTrail, is CloudTrail takes over a lot of our change record. Okay? Any infrastructure level changes are being logged automatically. All you have to add in is the why. So if you add a new instance, it gets logged through CloudTrail. You make some changes into these services, they get logged automatically. You have no choice. Nobody has to remember to make that record. It's being made for us in the background. You simply need to add in the why afterwards. So that's a huge plus for us. Then you add to the fact that the vast majority of the deployments are using some sort of configuration management service. We might have learned something new about that this morning, right? One of the big announcements. Fantastic. Because that's now taking it up a level and not just saying our infrastructure changes, but the things that are running our instances are now being tracked by a central service. A lot of people today are using Chef or Puppet or SaltStack or Ansible. All these tools, you can pull the logs out of there, and now you know the configuration changes. So I pushed a new update to Apache at 10.02. That didn't really work, so I pushed a new one at 10.03, but that's getting automated. So the more places that you can put automation in place with accurate logging, the easier it gets to do your audit response. So there's no magic, though unfortunately we switched to PowerPoint because I like this slide because it's the one time that I feel okay using the sparkle animation. I firmly believe the sparkle animation should only be used if you have a genie, a magic wand, or a unicorn. If you do not have that on your slide, you should never use that animation. But fortunately for all of us, PowerPoint doesn't have it. So I'm going to show you another really fuzzy demo. And what it is, or it's not fuzzy. Fantastic. So that was our same chat room. And what it is this is what's underneath that chat room. This is a console output of a combined log stream from CloudTrail as well as our security tool. So these are both logging through to SNS. And in this case, it's Trend Micro's Deep Security is pushing through to SNS. And what we've done is merge them. We've sent them to the same SNS topic. And it's a very simple HTTP endpoint. So it's sample code that I pushed up. It's not production ready, but it's good to illustrate the point if you want to run through and see the value here. So what we've done is been able to automate this, and that's where all of our chat room activity came from key events here. There's a lot of stuff that from an on-the-ground operational thing that we don't want to see, so we filtered it. Right? There's a lot of maintenance activity in the background of API calls and access calls that we don't need to do, so we filtered this stream as it goes. And as you look at the sort of the console output and kind of go, okay, great, yeah, that's a lot of text. What do I really care about? You'll see here in a second that every one of these lines is actually an individual JSON record, which means you can do a huge amount with those. You can store them in a database for analytics. You can kick them into the AWS data analysis pipeline. And that means every activity that goes back to any sort of logging is being recorded, and you can go back and do extra analysis for. So since we have one auditor, I will put him on the spot, because nothing says, I'm glad I came to your talk than getting called out in the middle of a crowd. But if you were able to come into somebody's operation and they could pull up a console because they've been logging all of their event activity, so here you see it as individual records, and they could ask you as an auditor and say, when do you want to see the point in time, the complete state of my deployment, how happy would you be?
There's a caveat every time you have an audit trail. An audit trail is
Absolutely.
So then the issue is, okay, how do they look for anomalistic behavior?
Yep. Yeah, so we would put eventing behind all of this and alarms and things like that. But as an auditor, if you came in and said, show me what your deployment looked like at Tuesday at 8:05, would you be a happy man? Absolutely. And you see why auditors get the rep? I ask him a simple question and he gets the caveat around it, right? That's the point of why auditors get the bad rep. But thank you for that. I do appreciate that. So the point is absolutely, you'd hook a lot of eventing around this so you'd be able to alert and alarm on anomalous activity, and you still have the operational aspect. But by leveraging some of the functionality that's available in AWS, what we've been able to do is take away the part of the audit that we hate. As operational folks, doing the paperwork is boring. Right? You don't want to sit there and fill in all this paperwork. That's why we have computers. That's why we have these systems. Why not get them to do all the heavy lifting so that we can add in the value? We can add in the why. We can add in the, okay, yeah, we did this because the business requested this unit and things like that. So we've been able to automate a lot of the heavy lifting to make it easier for us to respond and hopefully shift the relationship with the auditors and the audit team so that we're not so adversarial. So that's auditing. That's incident response. That's auditing. So I hope that you've seen that we can change how the perception of security is. And I like this little graphic because it always reminds me of Stuart Smalley from Saturday Night Live, right? He's looking in the mirror and he's all like, I'm good enough, smart enough, doggone it, people like me. So we can change that. We can have an attitude. I would much rather be this guy looking into the mirror confident than this guy who's pulling his hair out, or this guy who's running on the damn wheel all the time, right? I was doing security operations, in a 24/7 SOC. For federal governments, and it's a high pressure environment because you're always, the business is on the line, the organization is on the line, and it's uncomfortable, right? There's a huge amount of pressure, and it's on you. Even though you didn't cause the problem, you've got to fix the problem, right? So this is very accurate. The audit, this is very much how you feel, and that is a short audit report, okay? They're normally much, much bigger than that. So I hope that you've learned today, if we can leverage some of the power, if we can automate some of these tools, if we can think about security operations in a different way. So if you look at development and operations, right, the big buzzword, DevOps, security is always left out. But as security folks, we need to get in on that. We need to automate this. We need to take a different approach to how we do security. And the AWS cloud and the API and the infrastructure underneath that lets us do it if we take the right approach. If we look for the right tools, and if we look at redoing our implementations, we can pull this off. We can be the little guy shaking his hands, running across the line happy, as opposed to hiding in the SOC and trying not to make eye contact with everybody. So we've got some time for questions. Thank you very much. I appreciate it. So again, my name is Mark Nunakoven, Mark NCA. I have a tweet scheduled out in the next couple minutes with the URL. You can see the videos in HD, as well as the code example. So if you want to try this at home, you can do it. Questions? Comments? I will be after if you want to ask a question privately. I know some people don't like to do them up front. So we'll do that. Please remember feedback. This is Security 313. There's a feedback section at the side. I'll tweet that URL out as well. I would appreciate feedback, good or bad. Always good to improve. So thank you very much.